Hi guys, good day to everyone. Today we will try to model this screw jack. So if you look at the screw jack, we have 7 components. So it starts from body and ends at Tommy bar. So each component has been assembled for a single time. So we'll start with one by one. So first we'll go for a first component, which is body. So if you look at the body, so they are given only one diagram, which is the front view, and the dimensions are all specified in diameter, which means it is a cylindrical like shape. So we'll go for a revolve option to model this. Let me proceed. Open Creo. Set your select working directory. Let me select this working directory. Go to favorites. In here, I am going to create a new folder called as screwjack. So let me click OK with respect to that. Now let me click new. The first model, what you are going to do is body. Let me type it as a body. Uncheck this use default template. Select MMNS part solid. Click OK. So the first model will be a revolved option. So go to revolve, select the front plane, go to sketch view. At the beginning of revolve, first we have to put the center line. Let me put the center line with respect to that. So I am going to model this in a first quadrant. So let me zoom it a little bit. So I am going to model with respect to this. Let me start from this point. Let me draw accordingly. So we'll start from here. So I'm going to draw 2 lines with respect to this. So go to line. Let me draw 2 lines. So it shows some dimensions. Let me modify these dimensions. So one is 20, 140. This has to be 140. This has to be 20. Now the length with respect to this is mentioned as 100. So let me go and modify that. Change this to 100. So similarly, let us draw this part at the top. So since it is inclined, we can't able to draw this inclination. Let's try to draw this with respect to that. May give dimension for this. So one is 50. This is 50. The other one is 70 mm and the height is 40. This has to be 70 and the height is 40. Now you can able to see the distance from the top to the bottom is mentioned as 185. Let me mention that. So here this is the dimension which is representing from the top to the, not from the bottom to this point. Let me draw a dimension from the top to the bottom. This has to be 185. So this value is entered. Now we can able to see there is one more dimension here which is at diameter 66. So let me draw a line, a small line, and if this shows the dimension has to be 66. Okay, mention it accordingly. Now what you have to do from here 66, I have to connect with the other end. Let me connect it. Go to line. So from here I will connect with respect to this. So this side, the outer surface is over. So only thing is I have to produce a radius here. So radius we can do it outside. So the next part is we will go for this part, middle, this bottom surface. So we will complete that bottom surface based on the values given. You can able to see that I have to draw a line and it has to be at a diameter of 100. So let me proceed here. We draw a line from here. We'll draw a line somewhere here. It shows a dimension, change it to 100. Next, there is a 3 mm depth. Let me go to a line. I will draw a inclination like this. It's just a random one. So this alone, I will call it as 3 mm. Now, if you check here, you have an offset line of 10. Let me draw that 10 line, 10 mm line. So I have to offset this line. So you have an option here for offset. So offset, click offset, select this line alone. This has to be 10. We click OK. Sorry, you have to click OK in this offset selection. In this version, it shows like this. In older version, you will get it directly. Click. Now, this line has to be connected with respect to this. So I want this side and this side. So let us go for corner option. Click corner, select this line and this line. So the remaining part will be removed. Similarly, I will go for line. From here, I will draw a straight line so that it cuts that particular inclined line. So now I will trim this. Let me trim this line and this line. So now you can able to see this is the revolved face of your screw jack. So there is one dimension is not specified here. This dimension is not given in the diagram also. Okay, so it is just a intersection of these two lines, so which we have done properly. So let me click OK. So once this is over, we click OK. So now you can able to see the shape of the body. We click OK in this. The next step is, so here you have fillet, so which is of radius 8. Let me click round, select this edge and give the radius as 8. Click OK. So other than this, if you want, you can also give fillet inside. So I'm not going to give that. So this completes our body part. Let me click OK and save this file. Click OK. The next model is nut. So here you can able to see you have a sectioned view of this nut. It indicates that it's a revolved surface similar to your body. So the value here 50 R6 and in body also you would have seen H7. This indicates the tolerance value. It is not that H7 indicates hexagonal shape. Okay, so H7 and R6 indicates the tolerance value. So tolerance for hole and tolerance for the shaft. So let us try to model this directly by using a revolve command. So save this file. Let me close this. Create a new file. So name it as nut. Uncheck this. Click OK. Select MMN as part solid. Click OK. Now this is also a revolve command. Click revolve. Select your front view. Go to sketch view. Once you are in revolve command, first thing is you have to put the center line. Let me go to center line, draw a center line with respect to that. Now I'm going to model it in the first quadrant. Let me zoom it a little bit. So we will try to model these two lines. So I will draw these 3 lines with respect to that. So go to line. So we'll draw here 1, 2. Similarly here also 3. So both lines are equal. Okay. So show some dimensions. Let us modify that accordingly. So according to this, so you have 38 as your diameter. So double click this, change it to 38. The other dimension is 50. Change this to 50. Next, we will try to model this. So let me draw one line which is 10 mm and we will project it accordingly. We will try to complete this. We go to line. From here, I will draw a line like this. Okay, like this. We'll complete it like this. So this dimension is 10. Change it to 10. Similarly, this depth. So the depth is also 10. Let me go and change this depth. So it shows it is equal. So delete that equal. I don't want equal symbol. So instead mention as 10. The overall distance is given here. The overall it has to be 45. So this has to be 45. Next, it is asking what is the overall depth of this. The overall depth is overall diameter is mentioned as 90. So this value has to be. See, all the values are specified. Only thing is I have to go for this particular arc. So the arcs are all comes under fillet. We will do it outside. So once this is over, you may click OK. So you can able to see this is something like a cup. Let me click OK. So in the diagram, all the radius was mentioned as 5. So let us fix that 5 and we will try to select the corners with respect to that. So go to round. So give the radius as 5. By pressing Control, let us select the corners. So first corner, second, third, and fourth. So you have 4 corners with respect to that. Select all the 4 corners, then click OK. So this completes our cup. So one thing what we are going to do is there is a thread which is inside. We refer you the diagram. So in the top view, it is mentioned as 38 into 7. It indicates that so you have a 38 mm diameter. The pitch of a thread with respect to that. The symbol here indicates there is a thread here. So the pitch is 7 and there is a square symbol indicating that it's a square thread. So we have to put a square thread of 7 mm pitch with for the diameter of 38. Let me proceed with that. So to do that, we go for helical sweep. So in this sweep, click the arrow on this clip. You have one more option which is called as helical sweep. Select that helical sweep. In the helical sweep, I have to select the helical profile. It is asking you to draw the helical profile. Let me click define. Select this front view. So select the front view data plane. Click sketch. Go to sketch view. So since I can't able to see what is inside, change your view type to hidden line. So now you can able to see this is the line. So go to references, select that line as a reference. So threading is like you are removing the material. So I have to make sure that the line has to be somewhat at the higher level when compared to this. Don't start from here. Draw a little bit higher. From here I will start, and here also I am just leaving some more extra lines. So this is my line where I am going to create a thread. So thread is also helical sweep. So I need to locate my center line also. Go to center line. My center line of this is this. Let me draw the center line with respect to that. So no need to worry about the length of this line. It has to be just outside. Let me click OK. So now it is asking a pitch value. So for us the pitch value is 7. Change this to 7. Next is I have to go for my profile. Okay, so you have a sketch section here. So click section sketch. So you can able to see there is a mark here indicating where you are going to draw my square thread. So since I want to remove the material, you have material here. Here this side you don't have material. So I have to draw the section here in this location. So draw a square section. Mostly the square section should be half of your pitch value. So since my pitch value is 7, this has to be 3.5. Okay, the square has to be at 3.5. Specify that. Now let me click OK. So you can able to see there is a thread which is formed. So let me change my view to shading with edge. So you can able to see this is the thread which is formed with respect to that. but this has to be removed. So click remove material. So now you can able to see there is a thread which is formed, which is inside. So in the cup, let me click OK. Okay, so this is how you can able to create a helical sweep for the cup. The modeling of this nut is also completed. Let me click save, click OK. The next one is screw spindle. Let me try to model this screw spindle. To model this screw spindle, you no need to concentrate on this inclined edge because it's a chamfer. So we will go for a flat one. Later we can make it as a chamfer one. So save this file. Let me click file, close, click new, screw spindle, screw underscore spindle. Uncheck this use default template, click OK. Select MMNS, path select, click OK. Now this also comes under revolve command. Click revolve, select the front, go to sketch view. I will draw the center line horizontally. Okay, we will try to model it in the first quadrant. So we will try to model this randomly. So we go to this line. I'll start from here. So the model is like this. Okay, this is my rough model of this. So let me change the dimension with respect to that. So first you start with the minimum value of dimension so that the shape won't change. Otherwise, you can also go for modify command, select all the values with respect to that and change it. So the first one is having a diameter of 22. So this has to be 22. Double click, change it to 22. Next, the depth is 13. This has to be 13. Next, this entire depth from here to here, it is mentioned as 83. So the dimension from here to here. So I will create a dimension. Go to dimension, this surface to this surface. So this has to be 83. Okay. Next, the total length is the total length is 240. So this has to be 240. Double click, change it to 240. Next we have one more. This one, it is mentioned as diameter 65. So this value has to be 65. This has to be 65. Sorry, this is not this entire thing. It is one. This is for the spindle. The spindle is 38. Change this to 38. Let me create one more dimension with respect to this. Go to dimension, select from here to here. So show some equal to symbols. Delete that equal to, equal length. So this has to be 65 by 2. This dimension has to be 65 by 2. 65 divided by 2. Okay. So this is my screw spindle. So most of the dimensions has been mentioned here. So this part is over. Let me click OK. So I'll get a screw spindle like this. Let me click OK. The next step is we'll go for this chamfer. The chamfer is 10 into 45 degree. Let me proceed with that. So click chamfer, select 45 into D. D has to be 10 here. Specify this edge by pressing Ctrl. I'll select the other edge also. So this is my chamfer. Let me click OK. Next, Here one more chamfer here. It is 2 into 45. We go to chamfer, select this edge. Okay, this the diameter. So 45, the diameter is 2. Select this edge. Click OK. Next, you have a hole at the center. The distance of the hole is 35 mm. So from the edge, so it has to be 35, and diameter of the hole is 12. So let me go to extrude, select the front plane, sketch view, draw a circle. So the dimension from here to this point, this has to be 35. So the diameter of the hole is 12. We click OK. So when you do that, so it is creating a hole, but make sure it is a symmetrical hole. Just increase the distance so that the hole is coming outside. Okay, so you can able to see the hole is outside the surface. Let me click OK. So the next part is, so you have another threading here. So M12 thread. So this can be done by using a hole command. So let me proceed with respect to that. So here you should have that hole. Let me go to hole command, click hole command. I need hole here. So you have different options here. So but this is not applicable for the older versions. Let me select it directly. Let me select this hole. So I'm going to connect this. There are two lines, right? So these two lines has to be connected to the datum plane. So the first one, the dimension here is 0. The second one, which is related to this, the dimension for that is also 0. So this is not 3.7, it is 0. So now the hole is at the center. Okay, what is the diameter of the hole? Check it out. The diameter of the hole is 12. So here you go to standard size, click standard. It should be a straight drill hole. So you have a profile like this. Okay. It should have a taper. Sorry, some threading. Okay. So what is the screw size? It is M12. Go to M12. Select M12. And they are not mentioned anything about pitch. So select M12 1. Okay, it creates something like this. So if I just see what is happening here, we go to view, hidden. So you can able to see there is a hole which is drilled along with that. Okay, so go to shapes. So here you can able to see the depth with respect to that. Threading is only for 30. So changes to 30. Overall depth is 35. Okay, so 35 without considering that corner edge. So here there is a option up to shoulder is 35. So the correct thing is, check it out. So this is up to shoulder. There is one more up to tip. So our dimension is up to shoulder. So select up to shoulder and give it as 35. So the shape with the taper 30 and here it is 35. So we completed that particular values with respect to this. Okay, once this is over, let me click OK. See, you have that particular shape with respect to that. So it shows a indication that how much is the taper. So how much is the thread tap and how much is your drilling. So you can just click this to disable the values what it shows. And it changes to edge. So you can able to see there is a hole with respect to that. The next part is, so you have this thread. So the thread is for total distance, so but there is a 3 mm gap. So you have to make a thread with respect to that. And the thread is again, it is 38 into 7. So diameter is 38, what we mentioned, but the pitch value is 7. So let me go to helical sweep. Go to helical sweep. Select one of the, click define. Select one of the datum plane. Go to sketch, sketch view. Here I need this line as a reference. So go to reference, select this line as a reference. Now I'll put a center line at the center of this. This is my center line. And my line will start from here. It goes up to a particular distance. So to mention the distance, go to dimension. So from here to this, it has to be 3 mm gap. So we mentioned that. So other distance, you don't need to worry. It has to be cutted, removed properly. So I am just making a line outside this particular geometry. I may click OK. Now go to sketch view, click sketch, change the pitch value to 7. Click sketch. So here you have a box. So this is where the material is. So I have to put a box somewhere here, either here or here. Okay. So not on the top sides. When I put on the top sides, if you remove the material, there is no material here to remove. Okay. So be careful on that. Go to rectangle. Let me draw a rectangle with respect to this. So I have just drawn as a square. So the depth of the square is half of your pitch value, which is 3.5. We click OK. So now it creates a material. Click remove material. Right. So now you can able to see how your material has been made. So you can able to see a screw which is created with respect to that. Let me click OK. Okay, this completes our overall dimension for a screw spindle. The next one is cup. So we'll try to model this cup. So cup also comes in under revolve command. So we have to draw this particular shape and we are going to revolve with respect to that. Let us proceed. Click new. Go to part. So name it as cup. Uncheck this use default template. Select MMNS path solid. Click OK. Now we'll go for revolve command. Click revolve. Select one plane. So let me go for a front plane. Go to sketch view. Since it's a revolve command, first let us put an axis. So this is my axis. So I'm going to model this in the first quadrant. We'll try to model it accordingly. So if I look at the figure, so this is the part which we are going to draw. So we'll draw a approximate sketch of this. Later we will try to modify it with respect to that. So since they are given what is the outer diameter of this, so we will try to model the first outer lines with respect to that. We go to line, we'll start from here. I'll draw something like this. So it gives some dimensions. Let us give the dimension according to the figure which is given. So there are 2 dimensions here and the other dimension with respect to that. So there is no angle here. Instead, we will create a dimension from here to here. What is the vertical dimension with respect to that? So now the inside diameter is 22.5. So this has to be 22.5. The outside diameter is 45. So this has to be 45. Total vertical distance is 42. And the outermost diameter is given here, which is 65. This is 42 and this has to be 65. So you can able to get a shape similar to this. The next is they mentioned that there is another line which is here at a distance of 6 mm. So I have to create an offset line with respect to that. So click offset, select this particular line. So the offset is in a different direction. Change the direction. This has to be -6 in opposite direction. Okay, so once it is over, let me click OK. So other than this, I will draw a line, something like this. So the length of the line, the vertical line, it is given as 12. So this dimension has to be 12. And if I draw a line with respect to this, okay, there is another line. I will going to intersect with respect to that. Let me trim this. Trim these two portions. So this distance, they are mentioned in a different value. So if I refer, the distance is diameter 38. So let us change this to 38. Next, so we have to complete this in an horizontal way. So let me go to the line, draw a horizontal line. So remove the other segments. So this is our model. We refer, there are some lines here indicating that that is based on this particular arc which is done on both sides. So the final model is this. After that, we will complete that. So once this is over, let me click OK. You can able to see the cup like shape is available here. Let me click OK in this. So next is we have to go for this picture, which is a radius of 5. Let us try to model that with respect to that. So I'm going to choose the center plane. So go to extrude, select the center, to sketch view. So I need this top edge as a reference. Go to reference, select that as a reference. Now go to circle, draw a circle. So the diameter of this is radius is given as 5. So the diameter here is 10. I click OK. So this has to be extruded on symmetrical way. Let me increase the distance. So this has to be removed. So I am increasing distance and let me go for remove material. And it looks like this. Let me click OK. Repeat the same on the other plane. Go to extrude again. Select this. Sketch view. So select this as a reference. And we'll draw a circle with respect to this. The diameter is 10 here. Let me click OK. Proceed the same. Go to symmetric. Remove the material and then click OK. So this completes our cup. Save this way. The next model is this washer. So we have to we have to draw this particular washer. This also comes under revolve command. Go to new, type it as washer, uncheck this use default, click OK. Select MMNS spot solid, click OK. So go to revolve, select any one plane, go to sketch view. So draw a center line with respect to that. Since here the axis is horizontal, I will proceed horizontally. So if you want, you can also do it in a vertical way. So go for axis, a center line in a horizontal way. Now I will try to model that. So it is like this. It's like a trapezium. The washer looks like a trapezium. So there are lots of dimensions here. So the washer looks like a trapezium. So I will going to draw like that with respect to that. Something like this. So let us check what are the dimensions available here. So you have outer diameter, so inner diameter, distance with respect to that. So, and this distance. So let us enter the value with respect to that. So the first one is 8. The total distance here is 8. Next, the distance with respect to this is 25. So this distance has to be 25. This distance is 14.5. So this has to be 14.5. Outer value is 35. So this has to be 35. And the angle here, the angle they indicated as 90 degree. So let us specify that. This angle has to be 90 degree. So I have completed all the values. If you have difficulty in modeling this, changing the dimension, you go one by one in modifying it. So since it's a new version, so once I change a particular value, all the dimensions changes accordingly and it fits accordingly. But in older version, so we have to modify the data from the minimum value. So wherever the dimension is minimum, we will start from there. So let me complete this. Let me click OK. So you will get a washer similar to this. So let me click OK. Save this one. So the next one is CSK screw. So this screw. So we have to model this screw. Again, this also comes under your revolve command. So let me close this. Let me save and close this. Now let me click open. I'll type it as CSK underscore screw. Uncheck this use default template. Select MMNS part solid. Click OK. Now go to revolve. Select any one plane. Sketch view. So I'll go for vertical way. So it will be model accordingly. So from here I will draw something like a screw. Okay, it also shows some dimensions with respect to that. So let me show this dimensions. What are the dimensions? So you have this vertical angle, distances with respect to that, this and this. So you also have vertical distance. So the distance from here to here is also given here. Okay. So the overall value is 30. Double click, change it to 30. So so it will be like this. So in older version, if we do something, so just look at the dimensions which is specified. So all the dimensions is given. So click modify. Let me select all the dimensions whichever necessary for me to modify. Uncheck this regenerate. Let me enter it one by one. So this value, let me check it out. This has to be 24. So this has to be 24. Next, this distance, it is 6. Next, it is called as M12. So when you called M12, the diameter is 12. So this has to be 12. And overall distance is 30. Enter all the values, then click OK. So now you can able to see the screw is modified accordingly. So let me check what is the angle. So because the dimension is given for that, let me click this and this should be 45 degree. So it is showing as 45. So let us undo it. So because they mentioned as 90 for the overall, so since the dimension is specified accordingly, it has to show as 45. So since all the dimensions is over, let me click OK. So we can able to see this is our screw type. Let me click OK. Let me go to extrude, select any one face, sketch view. So draw a rectangle, something like this. You check here, the slot is 2 mm and the depth is 3. So let us create a dimension from here to here. The depth is 3 and this has to be 2. So this has to be 1. Okay. So let me click OK. So just make sure it is a symmetrical one. Increase the dimensions and click remove material. So this will make a slot. Let me click OK. Next, you have a chamfer here and a thread related to that. Let me complete that. So for chamfer, click chamfer, select this edge. It has to be at 1 mm. Okay, since the thread is very small, give 1 mm with respect to that. Next, we'll go for helical sweep. Go to helical sweep. Select one of the datum plane. Click define. Select a datum plane. Go to sketch. And sketch. So if you look at here, so your screw is up to a particular distance. There is around 2 mm gap. So it is not mentioned here. Let us draw a thread. We will make a thread with a gap of 2 mm. So first we have to put a center line with respect to this. Let me draw a center line. Now go for reference. Select this as a reference. Okay. Go to line from out. So go draw a line with respect to this. Okay. Go to dimension. Select this 2 points. I'll give 2 mm gap. Okay. So since it is M12 bolt, the screw. Since the screw is M12, the pitch will be around 1 mm. So the cross section will be 0.5, half of the pitch value. We click OK. Give the pitch value as 1 and go to sketch. So in the sketch view, we have to draw the sketch, a triangular sketch which is inside. So go to a line. Let me draw a triangle which is inside. So this has to be an equilateral triangle. Okay, sorry. So this has to be an equilateral triangle. So let me click equal, select the lines with respect to that. So these are all equal now. So the pitch value here, sorry, the section value here has to be half of the pitch value, which is 0.5. Okay, let me click OK. So it is adding a material. Let me click remove. Okay, so it creates a thread. Let me click OK. This completes our CSK screw. Let me save this. The last one, which is a Tommy bar. So if we go for a Tommy bar, so it is a straight object which is respect to that. So you also have a knurling with respect to this. So we are not going to concentrate on knurling. We will try to model this Tommy bar alone. Okay, so this is a revolved type of object. So let us go for revolve. So save the file and close this. Let me open new. So type it as TOMMY, Tommy underscore bar. Uncheck this use default template, click OK. MMNS part solid, click OK. Now go to revolve, select any one plane, go to sketch view, draw a center line. Let me draw a center line horizontally. I'm going to model it in the first quadrant. I'll draw something here from here. Okay, so we will draw from here. Okay, so go to line, draw a line like this. That's how the Tommy bar is. So just drawing a rough sketch of this Tommy bar. So we know overall distance. Let me click dimension, overall dimension with respect to that. Next, we check it out. This dimension is to be 62. The diameter here is 12. So this has to be 12. Okay, and dimension with respect to this has to be 62. Next, the angle with respect to this 45. So we'll go for dimension. Let me create a dimension with respect to this. So I am creating a dimension from the overall. So this is 45 plus 90. So 90 plus 45. So it has to be 135. Now let us go for the depth. So this so the overall diameter here is 20. So this has to be 20. Let me double click this, change it to 20. And the overall distance of the Tommy bar is 275. Change this to 275. Okay, so this is our Tommy bar. Let me click OK. So I can able to see it is revolved accordingly. Let me click OK. So the end is to be in a curved way. So the dimension is not given properly. If we want, we can able to create that also. So to do that, I'll edit this. So it is not necessary actually, but if you want that end to be a curved one, we go to arc, go for center end, we'll go for any point here. Okay, so we'll start from here and goes like this. Okay, so start from here, from the end point, go at a particular distance. So it is giving a radius of 24. Let me change it to 25. Okay, so let me delete these segments. I don't want these two segments, right? So now the Tommy bar will be a curved part. If you want, you can also do that. So we are not going for knurling operation because as it gets more featured value, so it will give some graphical issue. So we are not going for knurling. So let me save this. Okay. So this completes our Tommy bar. So let us save this, then click OK. So we have completed all the parts in our screw jack. The next step is we will go for assembly. Thank you.